In the second part of the lecture, we will introduce the Scikit-learn library. We will focus on supervised learning, regression, and classification. Scikit-learn is a Python library of machine learning algorithms with consistent and user-friendly application interface. For the 4 types of machine learning tasks that we learned in the first part, it offers 4 types of objects that are called regressor, classifier, clusterer, and transformer. Each type of object has prescribed methods it needs to implement, and we will list the most important ones here. All 4 types of object need to implement a method fit that fits the model to feature matrix, and if it's a supervised task, then also outputs Y. Method predict applies fitted model to a feature matrix and returns predicted outputs. This method is implemented for regressors, classifiers, and clusters. Method score returns an evaluation metric for regressors and classifiers, so only for the supervised methods. And method transform applies feature transformation for transformers. And fit transform first fits the model and then applies feature transformation. So we will now demonstrate the application interface of a regressor object using an example of linear regression. We will follow these steps. First, we will prepare the data. Then we create the linear regression model, fit the model, evaluate the model, and predict outputs on the new data and plot the model. The code that follows is also provided in a Jupyter notebook, starting with Scikit-learn that is available from Kit. Before we can start training machine learning algorithms, we have to get the data. And for that, Python package pandas is really useful. It offers extensive functionality for manipulating tabular data. And it has functions to import data from Excel, comma-separated value files, and pickle files. Here you can see an example of importing CSV files. So we use function read CSV that will return a data frame object that is native to pandas. And the example that we are using is the prediction of neonatal brain volumes that we introduced in the first part of the lecture. Now that we have created this data frame object, we can look what is in it by printing the first few lines using the function head. And we can see that we have the first column with gestational ages and second column with brain volumes. Each row corresponds to a different sample, which is a baby. Now we are going to create the feature matrix X and the target vector Y. We will first convert the data into a NumPy array, and we can use data frame function to NumPy to do that. And then we will extract the feature matrix, which is the column 0, gestational age, and the target vector, column 1, the brain volume. 2 things to note. First of all, we need to reshape the feature matrix into a 2D array. The reason is that we have only one feature, so this will return a one-dimensional vector, and Scikit-learn objects require 2-dimensional matrices. Second thing to note that Scikit-learn objects can also work with pandas data frames, so we would not necessarily need to convert. So finally, we are now ready to start using scikit-learn methods. So we said that we would choose a linear regression model, and because we have only one feature, this model will be univariate. So here is the equation. So this is the feature, this is the target value, and we have two parameters, W1 and W0. Here is how we import the linear regression object, and then we create an instance of this object, which is our model. Fitting the model is very easy. It's just model.fit. And this is done by minimizing sum of squared errors between expected and predicted target values. Once we fitted the model, we can access the fitted model parameters. W0 is in the member variable intercept, and W1 is in the member variable coef. Coef is actually an array, but we have only one value because we have one feature. In general, there will be as many coefficients as there is features. And finally, we print out the equation of the fitted model. Next, we will evaluate our fitted model. So that's very easy as well because it's just model.score. And for regressors, function score will return R2 score. R2 score is a proportion of total variance in the data explained by the model, and the perfect fit results in R2 score equal to 1. We see that we achieved R2 score 0.84, which is very decent. So linear model was quite appropriate for our example. Now that we fitted and evaluated the model, we are ready to predict on new data. But we don't have any new samples at the moment, so we're going to create some. Because we want to plot the model after this, we will just sample the whole feature space, which is 29 to 45 weeks of gestation, and we will take 10 samples in regular intervals between the minimum and maximum value of this feature space. And for that, we use NumPy function linspace. And here is the printout of our new feature space. You can see all the values, and you can see as well that it's enclosed in two pairs of brackets, which means that it is a 2D array, which is what we wanted. Next, we are ready to predict the target values for these new samples, and this is very easy again, it's just model.predict. And if we print that out, we see that we have a one-dimensional array of the values that are the brain volumes for these gestational ages. Now the last thing is to plot our result. And for that, we will use the library matplotlib. This is a Python library for visualization and is very similar to MATLAB. So we need the object pyplot from the matplotlib library. And also we need to put this line matplotlib inline. This is particularly important for Jupyter notebooks because it makes the plots appear and also to be stored. Now we can use function plot, and you see that it's exactly the same as in MATLAB. We have X values, Y values, and here we say what kind of plot we want. So we chose blue circles, and we chose transparency 0.5 to make the plot look nice. And then we also plot the model, and for that we choose solid black line. And finally, we annotate the plot. Now I would like to do a short demo of the Jupyter Notebook starting with scikit-learn. We start with loading the data using pandas package. And here we can see the data frame object. Next, we will create the feature matrix and target vector. And here we'll also print out the dimensions so we can see we have 162 samples and only one feature. Next, we will create the model, fit the model, and print out the parameters of the model. We'll calculate the R2 score, which is 0.84, and then we will predict on new data. So first we create the feature space and predict on the new samples. Finally, we will plot the results, and you see we got exactly the same plot as you've seen in the lecture. Next, there is an exercise for you to do. We will switch the role of the features and target values. So now volumes will be the features, and we will predict the gestational age of the baby. The feature matrix and target vector were already created for you, and your task is to write scikit-learn functions to create the model, fit the model, and calculate the R2 score. Then the R2 score and the equation of the model will be printed, but these commands were already written for you. You can now pause this video and do this exercise, or alternatively you can keep watching and do it at the end. There is also a video available on Kids showing the solution to this exercise. Now we will demonstrate the application interface of a classifier object in scikit-learn. We will train a perceptron classifier to diagnose heart failure. This is a classification example that you've seen in the first part of the lecture. When we load and display the dataset, you can see that in the first two columns, we have the features, ejection fraction, and global longitudinal strain. And in the last column, we have a label with 0 corresponding to healthy volunteers and 1 to heart failure patients. To make sure that the perceptron works properly, we need to scale the features. And for that, we will use a scikit-learn object standard scaler. This object will standardize features to 0 mean and unit variance over all samples. This is actually a transformer object, so we can use fit transform to apply the feature transformation. Now you can see that we extracted first two columns of this data to create the feature matrix, and the last column, which is the label, to create the label vector. One thing to note that now we have a two-dimensional feature matrix because we have two features, so there is no need to reshape. So here we can see how we can import and create an instance of a perceptron model. And a perceptron model will fit a linear decision boundary. So this is an equation for two features, x1 and x2, and you see that we have 3 parameters to fit. The fitting is performed using the function fit, and for perceptron, it will minimize the perceptron criterion. The perceptron criterion penalizes misclassified samples proportionally to their distance from the decision boundary. Once we fitted the model, we can print out the fitted parameters. We can access them using member variables intercept and coef, just like before. But there is one thing to note, that we have an extra dimension here. This is because we can have multiple decision boundaries, and this is to allow for more than 2 labels. And finally, we print out the equation of the fitted decision boundary. So we are ready to evaluate, and for that we use model.score. as before, but for the classification models, it will return accuracy score. Accuracy is simply a proportion of correctly classified samples, and perfect fit will result in accuracy equal to 1. You see that we have achieved accuracy 0.96, which is quite high. Final thing we would like to do is to plot the classification results. So we have two features, so we can plot the first feature on x-axis, the second feature on y-axis. And we will also need to plot different classes by different markers. So we can do that using a function plot again, but this time we need to select the samples with particular label. So in the first line, we selected label 0. So we get healthy patients, and for those we chose blue circles. Is here. And in the second line, we selected label 1, which is heart failure patients, and we print them with red stars. Now we need to print the decision boundary. We will do that by first finding minimum and maximum of feature 2. We put them into a NumPy array, and then we calculate values for feature 1. And the way we do it, we rearrange the equation for the decision boundary and calculate these two values. And after that, we are ready to plot. And here is the decision boundary. Now is the time to test your knowledge. Download the Jupyter Notebook 2.1 starting with sklearn, which is available from Kids if you haven't already done so, and complete the exercises 1 and 2. Solutions to these exercises are also available as a video from Kids if you wish to watch it. The exercises shouldn't take you more than 5 or 10 minutes. And when you are done, you can watch part 3, starting with Scikit-learn, which will focus on unsupervised learning.